Una Kim, who is Head of Research and Development at UDG Alliance and a board member of IoT Lab in Switzerland. She's also a science advisory member of FIWARE and an independent expert of the European Commission. And for the past, with more than 25 years of her experience in research, she has been working in several European research projects on IoT, data interoperability, data privacy, 5G, smart cities, smart water management, smart energy, and future networks. And she received a master's science and PhD degree in computer science from university in Korea. So now you have the floor.
Thank you very much, Anna. Thanks for joining the session. We have a relatively small number of audience today. It is the last day, it's a bit pity, but I think that we will have a fruitful discussion, hopefully. As Anna introduced me, we'll shortly introduce you about the data interoperability side. UDG Alliance is the responsible partner of the IoT platform building on the NIADES project. I will shortly explain what's the concept of the NIADES, and then we'll focus on the data interoperability side. NIADES project is with the 18 consortium partners. We aim to provide a smart water management specifically for aiming to the Sustainable Development Goals. And we have 3 pilot projects. One in Spain, Alicante, one in Switzerland, Garus, and one in Romania and Borrelia. So we are, beautifully, located in Southern Europe, Central Europe, and the Eastern Europe. We didn't actually plan it, but our city, the initial is the ABC. So that will make a quite, nice work together. Each city has a different environment, natural environment, and the water resource is also in a different situation, and they have a different requirements. So what the other partners are doing is to provide the solution for them. So quite nice thing about the NIADES that we have 2 utility companies that directly talk with us and then actually work as a partners. They give us the clear requirements and then also data, and then they validate things. And one is the city, municipality, so the city of Garus. They, while we always talk about the water utility side for the water management in urban side, Garus actually the target their requirements as a consumer of the water. So you will see there's some different requirements for that. I think that the detailed things will be about the pilot requirements. We have an afternoon session. I hope that you stay during the day so that you come on our afternoon session, that you will hear from the city directly what they are actually aiming for, and then what we are doing for them, and then also we will ask your opinion, as a feedback, and it's the co-creation session. So I think that you will hear more there. So I will not go into detail for your curiosity for the afternoon session. Today I will more on focusing on our platform side. So our platform is the build with the whole ecosystem of the water management. So we have directly from the city side with the infrastructure, and then we have a 3 edge cloud part to collect and aggregate the data from the directly to the edge infrastructure, and then we have a platform in the central cloud, and then of course we serve the end users with that. The most important part of the platform that we put the data interoperability as a key. So from the edge side, when we collect the raw data, then we provide the common data models and also open standard APIs. And this whole data is through the cloud with the identity management and access control and also data integrity, who will be introduced by our colleague later. And we try to provide the interoperable and scalable and secure platform. I actually want to talk about the data interoperability as a key, and I want to introduce you this short video. You know, compared to the time that I have here, I think it's a relatively long one. It's a 5 minute of video, but I think that his lecture is much more effective to deliver the agenda, why we are talking about data interoperability and why everybody talk about data space. You know, if you attend the session from the beginning of the IoT week, I think it's a really big, one of the big agenda was the data space. And then a lot of projects, they presented about their work on the data interoperability and how they build the platform thing. So I think that instead of repeating things, I think that we'll just show you this. This video will be from the Professor Hans Rosling from Sweden. Maybe some of you already know it, but if you do not see it, the full video is in YouTube. I love this. I watched it several times. Actually, his presentation is not about this engineering, that how we build a platform and then bring the data. But he, as a data scientist, he showed why data is important. So I think that can give some sort of the answer. So that I will play the video.
About 10 years ago, I took on the task to teach global development to Swedish undergraduate students. But when you get that opportunity, you get a little nervous. I thought these students coming to us actually have the highest grade you can get in Swedish college system. So I thought maybe they know everything I'm going to teach them about. So I did a pre-test when they came. And one of the questions from which I learned a lot was this one. Which country has the highest child mortality of these 5 pairs? And I put them together so that in each pair of country, one has twice the child mortality of the other. And this means that it's much bigger the difference than the uncertainty of the data. I won't put you at a test here, but it's Turkey which is highest there, Poland, Russia, Pakistan and South Africa. And these were the results of the Swedish students. I did it so I got a confidence interval which was pretty narrow, and I got happy, of course. I had 1.8 right answer out of 5 possible. That means that there was a place for a professor of international health and for my course. But one late night, when I was compiling the report, I really realized my discovery. I have shown that Swedish top students know statistically significantly less about the world than the chimpanzees. The problem for me was not ignorance, it was preconceived ideas. I did also an unethical study of the professors of the Karolinska Institute that hands out the Nobel Prize in medicine, and they are on par with the chimpanzee there. So this is where I realized that there was really a need to communicate, because the data of what's happening in the world and the child health of every country is very well aware. So we did the software which displays it like this. Every bubble here is a country. This country over here is China. And this is India. The size of the bubble is the population. And on this axis here, I put fertility rate. Because my students, what they said when they looked upon the world, and I asked them, what do you really think about the world? Huh? And they said the world is still we and them. And we is Western world, and them is third world. And what do you mean with Western world? I said, well, that's long life and small family, and third world is short life and large family. So this is what I could display here. I put fertility rate here, number of children per woman, 1, 2, 3, 4, up to about 8 children per woman. We have very good data since 1960 about, on the size of families in all countries. The error margin is narrow. Here I put life expectancy at birth, from 30 years in some countries up to about 70 years. And 1962, there was really a group of countries here that was industrialized countries, and they had small families and long lives. And these were the developing countries. They had large families and they had relatively short lives. Now what has happened since 1962? We want to see the change. Are the students right? It's still 2 types of countries? Let's see. We stop the world. And this is all UN statistics that has been available. Here we go. Can you see there? It's China. They're moving against better health. They're improving there. All the green Latin American countries, they are moving towards smaller families. The yellow ones here are the Arabic countries, and they get larger families, but longer life, but not larger families. The Africans are the green down here. They still remain here. This is India. Indonesia is moving on pretty fast. And in the 80s here, you have Bangladesh Bangladesh still among the African countries there, but not Bangladesh. It's a miracle that happens in the 80s. The imams start to promote family planning, and they move up into that corner, and in 90s we have the terrible HIV epidemic that takes down the life expectancy of the African countries, and all the rest of the world moves up into the corner where we have long lives and small family, and we have a completely new world. We find that students get very excited when they can use this. And even more policymakers and the corporate sectors would like to see how the world is changing. Now, why doesn't this take place? Why are we not using the data we have? We have data in the United Nations, in the national statistical agencies, and in universities and other non-governmental organizations, because the data is hidden down in the databases. And the public is there, and the internet is there, but we have still not used it effectively. All that information we saw changing in the world does not include publicly funded statistics. There are some web pages like this, but they take some nourishment down from the databases, but people put prices on them. Stupid passwords and boring statistics. And this won't work. So what is needed? We have the databases. It's not a new database you need. We have wonderful design tools, and more are added up here. But what we really need is, of course, a search function. A search function where we can copy the data.
Yeah, I will continue a bit, but I just want to just shortly break here, because you see the message. It's not about the water things. It's all about the data. And that this message, actually this is from the 2006. Surprising, isn't it? So we have all this data, but we just do not use it. So that we have this preconception, and then we are still the way of we have a silo. So of the data, so that in 2022 we are all talking about the data interoperability, and then we want to build the data space on in the now sector and then cross sectors and so on. So I think that this is the very nice the presentation that he made in 2006 with until the data of the 2003. So what we are doing here, all gathered together in the different sectors from yesterday and today in the water also, what we are doing in here is to really make this, the flower blossom, so that there is this missing part of the connecting the hidden data, and also create more data to create and then provide to the publics and then more industries. I will continue and then see his message.
The data up to a searchable format and get it out in the world. And what do we hear when we go around? I've done anthropology on the main statistical units. Everyone says it's impossible. This can't be done. Our information is so peculiar and detailed, so that cannot be searched as other can be searched. We cannot give the data free to the students, free to the entrepreneurs of the world. But this is what we would like to see, isn't it? The publicly funded data is down here, and we would like flowers to grow out on the net. And one of the crucial points is to make them searchable, and then people can use the different design tool to animate it there.
I just watched this video many times in the beginning. A few years ago, I watched this, and then that time I felt it's just very interesting. And then after a few years, we are still working on this making all the data connecting together, and then build a better world with that. So that I think that today when we talk about, especially nowadays, all the big concepts is a data space, and then I decided to bring it to I think it's much more effective than my presentation. Then his nice presentation, how data impacts change your mind and things. And then what's the missing part is that this kind of all the publicly funded data. We are working with the public fund, and then what we are doing is to go on the right direction. I think that's what we are doing here. So that the NIADES platform use the open standard APIs, because what we think that the key is to provide the data searchable, interoperable, and then from not only from our project platform, from the other side, it should be reusable, so that I think that then open standard API is the most important things, and that's what we are using in the EDGIS NGSILD, that the European standard. So many of the European projects are also using it. So or the data or platform that we created through the NIADIS will be reusable for the further project and the further use of the data. And then, of course, not only the APIs, also as a couple, the most important thing is the common data models, because each one has a different format of the things. Then it means that if you want to use the data, then you have to work a lot for making it readable. So I think that to avoid such things, when we could use the common data model, that would be the most effective. So we have actually the water cluster. We have a 5 project. We are working together to build the common data models. One part is that this Fire has some data models which you could reuse it, but specifically for water side, we do not have that full set of the existing data models yet. So through the use case with the bottom-up approach, we reflect the city's requirements and then put it update and then change the data models, and then we share it with other 5 projects in the cluster. We meet every second week and then share the result, and then also when there's a new data model is created through the use cases from the other projects, also we share and then share it in the smartdatamodel.org. So that of course that if the data is still is all distributed in a different way, and then it's hard to find the search, so hard to search. So we use the cloud platform, so that all the edge is sent to the cloud platform, and then of course the trust is very important. So that we will have a data integrity part for the other presentation. And very important thing is that nowadays it's not the top-down but the bottom-up approach, that we really listen to what the other world is using, not the engineering mindset, but the customer mindset is very important. As I said, what NIADIS, the important part is that we have a really directly the utility company and cities are validate our data and things. It's exactly that's how we want to fulfill the EU data policy, and then we believe that that's going the way right direction to go to achieve the Green Deal goal and also SDGs of the UN. So what NIADIS is doing, and then nowadays many projects are doing that we developed it as a DevOps mechanism, but then not only just the development and operations and going into this circle and give the input and output. We think that it's very important that from the very beginning that we put the data as the core set of the DevOps, so that I brought it from from the Snowflake, and then this is very nice to show it, so that how the data is from the beginning that it gets through to always through the circle of the DevOps, so that we call it they call it as a data ops. That I think I really love this word, and then I think that's how we go. So I just go a bit quicker. So that when we collect all this data interoperable, what we want to do, when we say about the data space and then reusable data, and that we create the innovation through the data, then basically what we are doing is just one example that we have this the smart water side. We have 2 use cases, I said, for the garage, and then let's say that we now change it to the NGSALD based on the common data models through all the other water projects, and then garage want to continue to doing want to continue their development, let's say, but then they do not want to reinvent the wheel, and then they want to also save the budget for creating the new project, and they could reuse it, and so they could easily add the new use cases, and then also they could build the new, combining the other parts of the project, and then they could combine the new set of the portal, and then these things can be replicable for the other, the neighbor cities, and then eventually, I think that's what we have to go. So it's a rather the short presentation, but I would like to emphasize that the reason why we talk about the data interoperability and why it's important. I think this is the most important part, the detail of technical side. If you contact to me, I will be happy to give you. And then about this user requirements part, we have an afternoon session, as I said, so that you can learn about the details of what we actually, detail the requirements, what we solve it there. And the other parts of technical sets for the AI and also consumer awareness and also the data integrity things will be also provided by my colleagues. Thank you. Should I get the question or no?
Thank you very much, Una, for your presentation. And now I would like to move on to the next speaker of the agenda today. We have Juan Fernandez Montenegro, who is going to be presenting also his presentation about AI services. So Juan finished his PhD in 2018 at Kingston University, working on Alzheimer's diagnosis, combining computer vision, machine learning, and virtual reality technologies. He obtained a master's of science degree in game development from Kingston in 2014 and has been working on virtual augmented reality project. He obtained also his master's science degree in telecommunications engineering with specialization on communication signal from the University of Vigo in Spain in 2010. His professional experience includes a position as researcher at the University of Vigo in 2013, focusing on medical image processing, and he's currently working at IMEN as artificial intelligence research and developer. Juan, you have the floor.
Thank you, Anna. So, yeah, I'm going to the presentation, 1 minute. Okay. So, continuing the presentation from Una, I will focus more in what is the purpose of Naiades as an ecosystem of smart water management solutions, and basically what's the architecture and what are the requirements for artificial intelligence solutions all together in the same platform. And let's go to the point. So basically the main objective of our platform is to offer a wide set of water management solutions. This is for this we require a platform that is modular and easily and very flexible, where you can modify, add and remove any new service, so it's easy to update the platform. As Una already said, the key point of this platform is the interoperability, so it is easier to share data, and that you can have data from different sectors, and that you can easily combine all of them. And also other important point is security, that is going to be discussed later in this session. And yeah, the final point that is the and ideally it will be good to promote the open and share the outcomes of the data, and related to this, so the management of data. Some key questions come when designing the architecture of Naiades, and in this case the first question is where and how do you want the data to be managed, and there are currently different possibilities. You can have all the data managed in a central by a central entity that will manage and share all the processes. You can have that management done separated in a decentralized way. So And finally, you have the distributed where each edge will manage and share the data by themselves. So all of them has their benefits and their drawbacks, but essentially, mainly, all these technologies are moving to a distributed management. It is more complicated to manage, but at the end is the one providing the more benefits in terms of security and scalability. And the other interesting question that was important for the design of our architecture in Naiades is where do you want the computing to take place. This is important in this case because in Naiades we focus a lot in artificial intelligence solutions, and they are quite computing extensive, and so it's important where do you want to have the computing capabilities. That could be on the edge, on the end user side, or it can be in the cloud, so the resources for computing are just shared. So, yeah, when it comes to Naiades, our platforms share those objectives to provide a wider set of smart water management solutions that are with easy access, interoperable, modular, flexible. And what we have designed is a platform whose core is based on complying with fireware. So we have a hybrid cloud solution that it allows to have the solutions directly on the cloud, or you can have them on the edge and just share the information. And basically, the current solution for Naiades, because we want to have a final solution at the end of the project. It is a centralized data management that is the core of this platform is the fireware Orion context broker that is capable of manage the centralized context information, mainly for real-time data sharing, and it allows also to have cloud fog and edge computing. And we also have one historical central database. This was mainly created to make it easier for the artificial intelligence that use the historical time series to have access to this information. And we allow to have centralized and decentralized processing. Going to move to the next one. So basically this is a summary of the Naiades platform, where we have the core that is the Orion context broker, the fireware components, and we have a set of centralized service like the water demand forecast, water quality forecast, ESS, weather forecast, anomaly detection, dynamical treatment suggestion services. These ones have been created for the project to be applied on different use cases, and the aim is that anybody that wants to use those services connect to Naiades and ask if they prepare their data to be interoperable with Naiades platform, they can use and profit from those services. And apart from the internal ones, we also have a couple of external services that run in a different platform that is not Naiades, that in this case are the Water Observatory and the Consumption State Analysis that are running managed by the company providing these services and they are connected to Naiades, and they have also the data is secure and they have the right access to access the data. So, and finally, we have the marketplace that is going to be used to show the whole set of services that we have in Naiades. And so if any service providers want to join, they can see their requirements to join the platform, and also for the end users that want to hire some of those services, they know which type of data they have to provide. So while we focus in this project in artificial intelligence services, the platform is ready to accept any kind of service, but in this specific project mainly we focus in the artificial intelligence ones because the current research has proved that it provides benefits in the water sector, like reducing operational expenditure, and reducing energy costs, optimize the use of chemicals, the predictive maintenance of their infrastructures, and also the decision support system can help the users to understand better what's the information that they are managing. And also reduce water waste. So I'm just going to explain a little bit some example of the services that we provide at Nayades and some other services that could be included in the platform in the future. So the first one is about the dynamical treatment suggestions. The purpose of this service is to optimize the use of chemicals in drinking water treatment plants. The idea is that the service suggests the optimal treatments to be applied, dosages to be applied to the water that guarantees that with the minimal treatments you obtain always the expected water quality of the outlet. So this, the purpose of this service is just optimizing the use of treatments in drinking water treatment plants. So other example of a service that is part of the Nayades platform is the water demand forecast. That in this case, this specific solution is a hybrid solution between artificial intelligence and physical modeling, where the artificial intelligence predicts future water demand and for the following days. So taking that into account, the end user can estimate the amount of data that the specific district can need. And on the other side, the physical modeling uses the input of this artificial intelligence service to show the distribution of flow and pressure inside the network. So the next one that it looks quite uncorrelated, not related with water. So it is the weather forecast, and this is an important service included in the platform because some of the artificial intelligence require this type of information. And you can think that there are already services that provide the local information for many areas, but the purpose of within Nayades is that you can provide your own weather observed measurements. There's a specific use case when environmental station is used to have a more localized and close to the problem weather information, and also we need the predictions for that. So in order, that's the last service I'm going to present for Nayades. This is the Water Observatory. That's one of the external services, and this Water Observatory collects information around the world and present and also the localized information for each end user that is related with different water topics. It looks in research paper, news, and also in social networks, and provides useful information that for the end users related to the water, to have an idea what's going on. So just to the next two slides and final ones are just some recent research paper related with artificial intelligence and water solutions that could be applied on the Nayades platform, like detection of pollutants in the water. It can be the estimation where the pollutants came into the network. It can be also the project to design one of the infrastructure components on the water network. Also the prediction maintenance of the infrastructure, like this one, to estimate when a pipe is going to stop working or is going to be a failure in the pipes, or just to estimate the flood predictions in the network. So these and other solutions based on artificial intelligence could be future services on the NIADES platform. Yeah, I think I'm going to finish here. The next presentation should be related with other of the NIADES services, so you will have more detail about one of them.
Thank you very much, Juan. Now I have the pleasure to introduce to you Alenka Gucek, who is a researcher and data visualization engineer at the Josef Stefan Institute in Slovenia. She has more than 10 years experience in anomaly detection of time series from fields of electrophysiology and life cell microscopy. She obtained her PhD in biosciences from the University of Ljubljana and has been a postdoc at Uppsala University researching cell-to-cell communication. Her work is focused on water management and climate change visualizations. Alenka, you have the floor.
Thank you, Anna. Good day to everyone. So I work in the Artificial Intelligence Lab of the Josef Stefan Institute, where we are developing AI services for industry, NLPs or sensor data streams. And as you can see from my title, today I'll be talking about anomaly detection. And this won't be anomaly detection of your very low sugar levels just now before lunch, but it will be about the unwanted leaks in the water management systems that cause lots of financial and also water damage. And if that happens, at least there should be a system to immediately observe and report these leakages. As I had a very nice introduction by the two of you, thank you. The NIADES really strives for the holistic approach, and one of those is to really be able to handle the unexpected events with as little trouble as possible. And what we'll be looking at today are the three solutions that we co-designed together with the NIADES pilots. And I'll be showing them in this order. First I'll be showing the temporal, then the spatial and the state analysis. And then also some of the lessons learned while developing those services. So let's start with the Alicante use case, which indeed has a very nice location to the sea. But sea also means seawater, and if the salty water leaks into the wastewater system, this wastewater can no longer be treated. Therefore, the operator really needs to know if there is seawater in the system, not to put that water to be reused. And the way we are doing it, they were doing it before the NIADES. The operator was checking the raw signal from time to time, and this made it very difficult because the leakages of salty water can have very small trends, and by eye it's always much easier to observe big changes. And they had some kind of a warning system, but it was only triggered in crisis. So our job was really to create a very robust anomaly detection system using the data from the conductivity and level sensors that they have. And first, we wanted to create one anomaly meta signal that would combine both the conductivity and level data, but that turned out to be a little bit tricky due to different sampling and changing charge frequencies. So then we approached the raw signal that you can see here, one example of it in the blue. We broke these raw signals into a series of pre-processed signals, so-called, you could call them maybe substreams. For instance, those could be rolling averages or daily night averages. And then those were pushed into anomaly detector, which then created and once that was aggregated, we created the temporal anomaly meta signal. And you can see an example of that in the red trace. And then this anomaly meta signal then serves as a base signal for distinguishing relevant from irrelevant anomalies which are fed for the DSS. And since this is done on the data stream, we kind of wanted to provide a little bit of buffer capacity of the model. When developing these kind of systems, you ideally want to catch all of the anomalies, and it's always better to catch a little bit more than not to catch all of them. Since if anomaly goes undetected, that can cause much more severe consequences, as if the operator manually sees this, okay, so this was a false alarm. So now let's focus on the second, spatial leakage detection in Brăila, a city in Romania. In ideal case scenario, on a conference as we are today, an IoT device, so a sensor, would be placed in every node of the water network. So leakages could be directly identified by the sudden changes in the data stream. And then we wouldn't have any work. But due to the budget and technical limitations, sometimes it's really impossible to put a sensor in a node. This is not really achievable in real-life situations. And therefore, really looking for locations of a small leakage in such a huge area could be compared to looking of a needle in a haystack. Especially if you have like a very low percentage of nodes covered, so in our case 2.6. So we developed a solution around it, where we combined several different services. We developed an anomaly meta signal for Brăila, and then in the second step, that's fed in the approximate leakage location, then determines the search location for the accurate leakage location. And I will explain the two of them a little bit more. To determine the approximate leakage location, we joined our forces with the water experts from the AHI Institute in Delft, where they took the water distribution network of nodes for this pilot area that you can see here in the image. And they use specialized APANET software, which models water distribution, which enables to create simulated data of leaks at possible nodes for different scenarios. So for instance, if there is only one leak, or there are two leaks, or yeah, that's the scenario that we did. And what we did then, we then compared this 150 gigabytes of data, of simulated data, with the actual pressure values, since there is usually a pressure drop when the leakage occurs. And then we grouped those one-dimensional deviations into probability groups to really determine which area approximately could be responsible for the leakage. And then this approximate area was used is used to determine the accurate leakage detection, which has 4 movable noise sensors that can be moved around by the operators, and once they are installed in the field, and the search is triggered, the algorithm itself will calculate and determine which nodes the sensor should be moved to collect the necessary data. And this is kind of a repetitive steps. It can take a couple of steps for the operator that they have to move the sensors, and then at the end you get an accurate leakage location of where that is happening. And the very good news is that next to the 4 existing noise sensors, our partners have now installed more sensors, which will make the search of the leakages much faster and even more accurate. So this is really nice. And as the third solution, I would like to present the state analysis tool, which handles the multivariate data streams, time series data, and abstracts them in states and transitions. So this might seem a little bit of abstract. I came up with how you can how we can explain that. You take a bunch of spaghetti, a bunch of line charts, and you make meatballs out of them. And so what is the process to do this? We have first the static time series embedding to lose the temporal parameter. Oh, sorry. I should not do it like this way. And then as the first output, we have the point cloud, which is then used to create the states, which are the typical configuration of the temporal signal, summarized around this centroid, as you can see here. And then in the next step, we use the continuous time Markov chain to model the transitions between the states. And then we can also look at the hierarchy of these states and transitions at different levels. So let's look how this looks as a tool. So these multivariate time series are drawn as a static graph that you can see here. States are the nodes of the graph. So these circles and their size corresponds to the time that the time series were in this state. So here we have flow rate highest. So in water management, you would often have a high flow rate. So you can also see this from the size of the circle. And then also we have the transitions between the states. Sorry, this is a little bit too small. So you can see at what are the probabilities for the transitions to happen in between these states. And then we have some adjacent plots to look at the time series as icicle, to specifically look at the states and their values for all the different variables that we are feeding in. And also one can explore the temporal granularity. So why would that be useful? Let's look at an example. Let's say that we have selected an interesting state, and we want to see when this state will occur when we have the data streamed to the platform. We can actually attach an event to this kind of a state, which will then trigger an alert. So the operator will know that, oh, now our flow is no longer the highest, now it's very low, so maybe something happened and we should go and check. And a real added value is that we can actually set those events not just to the anomalous state, but also to pre-anomalous state. So hopefully also to be able to detect the anomaly before it even happens, which would really help to optimize the water usage and the costs around it for our end user. So with this I would like to finish and I hopefully demonstrated some of the technical aspects of the AI services to tackle the water loss more effectively. Thank you.
Thank you very much, Arinka. Now we have our final presentation by our speaker, Tuli Ramos from Guardtime. Tuli is a project manager at Innovation and Research Cooperation team in Guardtime. It's an Estonian system engineering company. She has a master's degree in physics from the University of Glasgow, and before joining Guardtime, she worked as a radiation safety specialist. As a project manager, she is currently involved in several H2020 projects, including NIADAS, critical chains, as well as an ESA project on using SATCOM systems to improve distributed ledger technologies. Welcome to me.
Thank you, Anna. Hello, everyone. So I work in Cartime, which is an Estonian system engineering company. And in Cartime, we have over 10 years of experience in the integrity domain. So today I will talk about data integrity, what it means, both in NIADIS and more in general. So first we'll start with what is integrity, then we'll discuss a bit why checking data integrity is important. We'll talk about the specific solution we have developed for NIADIS, and we'll finish with just some thoughts on the future of data integrity. So, what is integrity? Integrity mechanisms are used to ensure that the products are unchanged. So, for example, a real-life example of integrity is when you go and buy a tin of food. If the can is closed, you can be quite sure that the contents are the same that you expect. And it used to be very common to seal all the letters so you can be sure that the letter inside has not been switched. Data integrity ensures the data consistency throughout its life cycle, from the collection point of the data to storage, transport, and later using or analyzing it. This means that all data values are unchanged. And sometimes it also means that data format must be unchanged. And for data, for example, if an envelope is opened, the seal is broken, it's quite easily detectable by eye. The same if the food package is open at the shop, you're not going to buy it. But for data, it's very difficult to see the changes. So here are just two data sets that are very similar, and it's almost impossible to detect the change that's there. They're very similar, but there has been an integrity change. So why would we check data integrity before using it? So data is underpinning so many things in our economy right now, and it is predicted that it will only increase. So a lot of predictions, planning, and decisions are based on data. And if data has been modified, either maliciously or accidentally during the transport or storing process, the analysis will be faulty. For example, in data storage, depending on the type of database, maybe all the values were rounded up, and when they were later taken for the analysis, the values are not the same that were put into the database in the first step. So data integrity validation ensures that the data is unmodified and the data can be trusted. And it is important that data integrity can be checked long term and without using any secrets or passwords, because they will get lost in the process. And it's also important to note that while data integrity checking is important, it does not help if the data source, for example the sensor in this case, is producing faulty output. In NIADIS project, you have heard quite a lot about the architecture and where all the data is going. So NIADIS project uses a lot of data as an input for the various models and predictions, and you saw some of the tools of NIADIS in previous presentations. And data integrity checking is one of the steps in the project to ensure good quality input. And data integrity for all data sent to NIADIS platform can be verified. So how do we do it? For integrity validation, we'll go into a short course for cryptography first. So it is depending on cryptographic hash. And this is a one-way function that the significant change is detected in hash, which corresponds to a small change in data. It is also sometimes called fingerprint of data, meaning that if there is a small change, like you change the date of the document, the change in data hash is very significant. It is not just a small change in the hash. And hash function is only one-way function, so it is impossible to reverse engineer a document from just knowing the hash function. So it is important for privacy preserving verifications. And in our solution, data hashes are linked to KSA blockchain, which is a private permission blockchain. And the benefits of using KSA signatures include that they are independently verifiable, and they do not expire, and they provide a long-term forensic proof. And using KSA blockchain and KSA signatures overcomes several technical limitations of other blockchain technologies. And as you can see from the figure to your right, data never leaves customer environment. So it is not, no data is put into blockchain itself. And in NIADES, all data that is gathered from the sensors is signed at the source. The signed JSON is sent to data model validator, where the model is first validated. And the data model validator then forwards the signed JSON to KSI verifier for integrity verification. And for all NIADES data, data model and KSI signatures are both checked. And any issues for integrity are reported to the user of NIADES platform. So anyone who's planning to use the data will find out if the integrity is ensured before they are actually starting to use it. And for the points of just the end talk about the future, the importance of data is ever increasing with different AI services and predictions, and in our smart water and smart city environments. And we see the first industries and places that integrity insurance will be used widely are critical infrastructure operations, which includes water like we're doing in NIADES, but also in energy, in finances, and in healthcare. So, thank you.
Thank you very much to all of you for your wonderful presentations. I would like now to open the floor to our public in case there are any questions. Otherwise, I will also like to open the panel discussion with a couple of questions that we have for the speakers. First I would like to have open the discussion with Juan, who made this very interesting presentation about AI services. I believe you have a microphone over there that you can also use. Yes.
Okay.
Perfect. So I'd like to ask you, it's a very broad question, of course, but according to you, is the water sector ready for the digital future?
From my experience, I will say that it is on its way, but it's still far to reach that point. There are quite a lot of difference between water managers, but in general, I think that the digitalization point to go further in providing solutions is still not there. I think that the digitalization level of the water managers should be improved first, and then a lot of solutions can come.
Absolutely. I'd like to now also have some questions with Alenka. I'd like to ask you, how can water management technologies be integrated with other utilities in the future?
Yeah, I mean, as we have heard today from all of the speakers, we are really working in a direction of making it possible to integrate with others. So we are on our way.
Turli, what does independently verifiable integrity mean, and how does it work, and why would someone need it?
Independent verification of integrity means that to verify that the data is intact, you only need the KSA signature and the data itself. So it doesn't depend on any third party, or you don't even have that access to KSA blockchain after you have obtained the signature. So it can be done offline, it can be done without sharing any other type of data, so it's very specific. And independent verification is important for ensuring long-term integrity verification opportunities, because otherwise maybe operations will cease, the authorities and certificates will change, so it's difficult to know in years' times whether it's still valid.
Mm-hmm. And are the solutions developed that are developed in IADES also applicable to other areas?
Of course they are. Of course, as I mentioned in the end, it's important in other critical infrastructures like energy or finances.
Thank you. Una, I also have a question for you. Are there any missing technologies at the current status in order to make more data open and also to build European common data space for water?
Well, in general, as I said, I showed this video from the Professor Hans Rosling, and I think that still out there are a lot of silos. That to make it possible, I think that we need some sort of the open APIs to connect to the silo each other. So I think that yesterday we had a quite nice project launched on, and then I think that we are on the direction to go there. But the first step is like what NIADES is doing, that we are making the open API and then common data models, and then there are really not enough common data models yet. So we build data models which is fit to the NIADES pilot requirements, and then there is other projects also are doing. But there's out there the industry side also, they have a different requirements, and then such things should actually come in together. I think that this is the slow movement, but we are doing what we could do with the cluster project, to make a synergy. And also when we make this kind of the data is available, each data space should be connected together. Then that's another level of the federation. Then so far we do not have such APIs or components to connect the data space together. So yesterday also, I think the new project launched from the EU Research Fund, and then I think that to apply them we will need a few years still go. One way is to make certain components and the APIs, but I think the important thing is not to reinvent the wheel again, so that we have to see what kind of APIs could be really be used to federate and link such a data space together. So water side, if we just narrow down the water side, I think it's very important that our 3 pilot project has a very different requirements than Brasilia has a very old infrastructure. So that for such infrastructure side, and then you should build a new technology on top of it. Then I think that's the kind of different challenge than some cities has a very nice infrastructure, already provide the utilities, and then Garu's case, although they have a very old infrastructure, still they are managed by the canton level, so the city has a different requirement. So that, and Alicante is in the hoster city, then they have also like what Alenka mentioned, that some sort of the water management side, that is a different one. And then I think this is all about the urban water side. but we know that there is a lot bigger problem out there, outside of Europe about the desertation. And then other side of the world, they do not have enough water to survive and things. So I think these kind of things, the use cases should combine together, maybe the UN level, and then such things I think that we should go forward. So not yet. It's the short answer.
You just mentioned the UN level, but do you think that there are other actions, other stakeholders that can basically take care of realizing this water data space?
I think not yet, because for them the survivor is the situation that they have to survive. They do not have energy to care about data space yet. But I think that what we are here is that we go the one step toward the future, what we could do in here, and then this kind of technology should be transferred to them we are publicly funded project, so that I hope that these kind of things continued with further government funded from the rich countries and transferred to the countries which has the typical the water shortage problem. So I hope that under UN and then EU also have a Green Deal agenda, and then all this together, we hope that we manage to go there.
Thank you, Ana. I would like to go back to Juan right now and ask another question. Do you think that digital water solutions are going to resolve future problems? We're thinking of climate change or water scarcity or floods. Are these the ways to solve those problems?
I think that they are not going to solve them. They alone cannot do it, but they are helping a lot in solving some of those issues. There are solutions to reduce the amount, the consumption of water, to save energy. There are some solutions that are taking into account weather changes to be flexible enough to provide the optimal solution even when those expected changes due to the climate change will happen. So they will help and they will kind of alleviate the effects. But yeah, I think that they alone are not enough.
And in the same fashion, do you believe that AI services are going to replace traditional solutions?
I don't think they will replace. The current research are showing that for some specific problems, the AI are providing better solutions. But currently, AI are working mainly as black boxes where you don't know exactly what's going on inside those algorithms. So I think that they will need the traditional methods. So even if the results are better, to understand what's the reason of what's happening in the process.
Thank you, Juan. Can I just add to that a little bit? Of course. Yeah, so it's also like from our experience creating the AI services, it's really this trade-off of searching for the solution that is really going to be the best for what the problem is, because sometimes it can be an AI solution, but sometimes it can be a very simple function that you just apply. So it's not going to no, let's just go and do AI solutions for everything, but actually to find the most optimal solution. And it's awesome that we have this whole library of solutions that we can do, but we shouldn't forget about simple is sometimes the best. And to what extent then, Alenka, can AI services provide automation of the water management sector? Yeah, again, on the way there. I mean, there is, as also I was explaining with the anomaly detections, there are certain things that you can automate, but there, it's really hard to then close the loop completely, because it's
not everything can be predicted, so we shouldn't forget about that. To always have a person still looking over that knows what's happening there and understands how the service itself is, what it's doing.
Thank you. Tuli, you did mention your blockchain solutions, and I was wondering also what makes your blockchain suitable for ensuring integrity on IoT devices?
So KSI blockchain, as I mentioned, is a private permission blockchain which is really fine-tuned for very high performance. So we are talking about hundreds of millions requests per second. And it's also a very lightweight solution in compared to usual what you think about blockchain, because only the hash is used on the blockchain and not the data itself. So because of its lightweight and very high scalability, and the feedback time is usually in around 1 second, so it's more suitable for IoT devices than other blockchain applications.
Thank you so much. I would like to go back to Una. I would like to go back again to the topic of data. And what do you think of the barriers of more data to be open?
I think that, again, I will mention about the video that, each side of the data, generators, they have a fear to share it. First thing probably is about the data, if data is safe to share. So I think that there's one solution, Tuli mentioned about the data integrity. And the other one is also, a lot of, the fear about the sharing is because of the citizens' acceptance, because the water data is actually, especially when we talk about the utility data, then it's including the privacy data as well. So I think that that's also, we have to make it more sure about the public acceptance to go. I think that also, it's also the technology side, and I think that we should make it more, sure that how things are opening. But in terms of the data interoperability, we cannot take out the standardization, and then sadly there are really a lot of standard bodies. Then they want to make their standards to be used. So it's a sort of the hard as engineers then to find the right place to go, and then also many standards together. Then we have to think of the interoperability among the standards, and such things also still is a big barrier. So I think that we should work in a more collaborative way with a bigger goal. I think that. But that's what all the European projects are doing, but I think that we need more effort on it.
Thank you so much, Una. Just behind all of you, we see the wonderful boxes of the SDGs. And obviously, NIADIS is very much connected to this goal and this very important aim. So in that context, I also wanted to ask one question to Juan. And which is basically, is AI really helping the achievement of the SDGs, and to what extent? What are the possible applications of AI to support the SDGs?
Okay. Related to that, recently I've been checking an article that was published in the Nature Journal that says that AI is helping to achieve 79% of the SDGs in topics like food, water, health. So yeah, that's the one side that is helping, but there's also issues with the artificial intelligence that is affecting also other SDGs in terms of privacy, transparency, ethics, because yeah, at this point AI is mainly helping, but it needs to be much more regulated in order to solve those issues with transparency, and some of the algorithms are biased, so they are affecting, they're solving problems for some people but affecting others, so that there's still a lot of work to do to solve those small issues, but mainly I think that artificial intelligence is helping.
Do you expect also the architecture of the AI services ecosystem to evolve in the future?
Yes, I think so. For example, related with artificial intelligence that is evolving continuously. One of the last trends with the artificial intelligence solutions is called federated learning. That instead of sending data to train for the algorithms, those algorithms are trained on the edge. So the data is not need to be shared, and only the model parameters are shared and joined together to create a better model. So yes, I think that in the future the networks going to evolve to something like that. But I think that the current state is flexible enough to easily adapt to those changes. But let's see how it will evolve.
Speaking of the future, I would also like to ask then Alenka, which other technologies will drive the solutions of water management?
Yeah, I think it will be really this interoperability of getting solutions also from other sectors to get it to work, and providing the solutions for specific small use cases.
Thank you so much. All right, I think we have reached the end of the session over here right now, so I would like once again to thank our wonderful panelists for this very insightful presentation of NIADAS, and also for the audience to have listened to us. I would like also to take the opportunity to invite you to our afternoon session, which is going to be a co-creation workshop in which we're going to be working together using our phones actually to develop the solutions and discuss basically ways to improve water management. So I invite you all to participate in it. It's going to be a very different format from any other session that we have organized so far. And yes, we really hope to see you there. So thank you once again, and hope to see you in the afternoon.